In 2022, astronomers working with the Australian MWA radio telescope picked up a bizarre signal from space. Moreover, it repeated every 22 minutes. Astronomers started digging into past records and found that this same signal had been happening for over 30 years and hasn't changed during all that time. According to the scientists' calculations, its source should be somewhere in the Gautam constellation. Researchers keep proposing new theories about the origin of this signal, but no consensus has been reached because it's just too strange. What's really behind this mysterious signal, and why does it keep cycling for so long, unlike many others? So why do scientists consider repeating signals from space as something unusual? The first ones were discovered in 1967 using the powerful Interplanetary Cation Array. It detected a signal at a frequency of approximately 110 MHz, repeating nearly every second and a half. Initially, scientists even thought it might be a signal sent by an extraterrestrial civilization and named it LGM-1, standing for Little Green Men 1. After all known natural events involving the emission of various waves, such as the death of stars, are one-time events by default. Later on, astronomers discovered several very similar repeating signals reaching Earth from various distances. Scientists realized these were not alien signals but rather a completely natural phenomenon, just an anomalous one. Today, we know these signals are produced by pulsars, small neutron stars that often remain invisible to us. 99% of discovered pulsars are inside our galaxy. Overall, according to the University of Cambridge, we know about approximately 3,000 of them. That's 100 million times fewer than all the stars in the Milky Way. Pulsars have an extremely strong magnetic field, billions of times stronger than our Earth. This field causes these exotic celestial bodies to emit electromagnetic waves near their poles. Pulsars spin incredibly fast around their axis, spraying streams of low-frequency radio waves in our direction, kind of like a lawn sprinkler. But the signal detected in 2022 repeats much less frequently, in fact, as much as 1,000 times less frequently. Could it just be a very slow pulsar with such a cycle? In fact, it's a highly compressed dead star that spins so fast it can't just slow down. At the end of their life cycle, pulsars do indeed eventually shed their speed, but at the same time, their radio beams turn off. But the object GPM J11839110, emitting a signal every 22 minutes, is even stranger. When scientists delved into the archives with recordings of this mysterious signal, they saw absolutely no discernible pattern. The gaps between signals always amount to 22 minutes. The time window in which the signal appears always equals 6 minutes. However, within this window, the signal can last anywhere from 30 seconds to 5 minutes, and that's really weird. When scientists observe a pulsar, they expect to see bursts of similar intensity within a time window of less than a minute or slightly more than a minute. The mysterious signal is not only too long for a pulsar, but it's also irregular. It's just plain nonsense. In other aspects, it rather resembles FRBs, short-lived radio pulses lasting a few milliseconds. The first of them was recorded in 2007 at the University of West Virginia. Analyzing pulsar observation archives with the Parkes radio telescope, researchers noticed a singular but incredibly powerful signal lasting less than 5 milliseconds. It originated in the area of the Small Magellanic Cloud, 200,000 light-years away from us. Such an energy burst could only occur during the explosion of a supernova. Perhaps that's exactly what happened because this FRB was solitary. But in 2018, Canadian researchers registered the first repeating FRB whose intensity could be compared to years of solar activity. This immensely powerful energy flash traveled to us from 457 million light-years away, and it repeated every 16 days, appearing for 4 days, emitting 1 or 2 bursts per hour, and then vanishing for 12 days. This is eerily similar to our mysterious 22-minute signal. However, only about 3% of FRB signals repeat, and no one knows exactly what produces them. Some theories suggest that ordinary solitary FRBs might result from star deaths or the collision of 2 neutron stars, but such grand cosmic events definitely can't happen regularly at the same coordinates. Maybe some other theories explain the origin of these extremely abnormal radio transmissions. The repeating signals we're getting from space might be echoes of processes in extremely abnormal neutron stars. Their magnetic field is tens of thousands of times more powerful than regular pulsars. Robert Duncan and Christopher Thompson proposed the model of this exotic object in 1992 to explain repeating gamma bursts considered the brightest electromagnetic events in the universe. They named these objects magnetars due to their immensely powerful magnetic fields. Gaps between their flashes are irregular, but in a few tenths of a second, magnetars emit as much energy as our sun does in an entire year. But magnetars still today remain more of a theoretical model whose sole purpose is to explain repeating powerful gamma flashes. So what if one of these abnormal stars is producing our mysterious 22-minute signal? In 2020, astronomers were able to trace an FRB signal back to its source and discovered a magnetar near the center of our galaxy, 30,000 light-years away. The Dominion Radio Astrophysical Observatory telescope in British Columbia recorded 2 flashes within 28.9 milliseconds of each other, but they didn't happen again. When astronomers pointed their instruments to the area where the mysterious 22-minute signal was coming from, they indeed saw a compact object resembling a neutron star. According to scientist calculations, it should be at a distance of 15,000 light-years. If this is indeed a magnetar, its colossal magnetic field explains why the mysterious 22-minute signal is so powerful. But with the repetition cycle, a problem arises again. Over the whole 30 years of observation, scientists should have noticed some slowdown in the already slow magnetar, but no dice. Plus, some of these long bursts look way too weird even for such an exotic object. Nevertheless, scientists jumped on this lead because they've already seen a somewhat similar lighthouse magnetar. Using the CHIME radio telescope, astronomers caught the longest FRB signal in 2019. Compared to similar signals lasting a few milliseconds, this one was pretty long, 3 whole seconds. That's almost 1,000 times longer than other FRBs. But this wasn't its only quirk. This FRB created periodic peaks eerily resembling a heartbeat rhythm. Its source was found in a nebula inside the Milky Way, 9,000 light-years away. Astronomers think this neutron star is incredibly dense and has an enormously powerful magnetic field, but again, none of the theories explain why it rotates so slowly. The most plausible theory scientists entertain is that after the supernova explosion that created this magnetar, the remnants of gas and dust clung to the magnetic field lines, significantly slowing down its rotation. But what if there's a simpler and, at the same time, even more exotic explanation? Professor Tomori Totani and graduate student Yuya Suzuki from the University of Tokyo tried to unravel the origins of FRB signals and made a remarkable discovery. Previous studies suggested similarities between the radiation from neutron stars and solar flares, but new data show that's not the case at all. In reality, repeating FRB signals might have much more in common with an entirely different kind of cataclysm. Scientists conducted a statistical analysis of thousands of recently discovered FRBs. They compared the time and energy of radiation from 7,000 bursts from 3 different FRB sources. Then, using the same method, they compared the time and energy of radiation for solar flares and earthquakes in the KTO region of Japan. After that, scientists compared the results of all 3 phenomena and saw that FRBs statistically differed from solar flares and were incredibly similar to earthquakes. Neutron stars, especially magnetars, probably have a solid surface similar to a crust due to intense gravity. Because they spin at a crazy speed, even the slightest little shift leads to massive starquakes. So, Professor Tomonori is convinced that our radio telescopes are picking up signals caused by these exotic cataclysms. In other words, a massive amount of energy released during starquakes reaches us in the form of FRB signals. But these discoveries still don't explain why signals from space regularly repeat, because starquakes can't happen with such stable periodicity, just like earthquakes on our planet. Moreover, during a starquake, X-ray radiation appears, which has not been detected in the mysterious 22-minute signal. Could it be that despite all these modern discoveries, we still don't see the full picture? What if what we're actually hearing is the echo of the most exotic events in the universe? In 2021, astrophysicists Gustavo Magallanes and Sergio Mendoza from the National Autonomous University of Mexico recorded bursts of X-ray and gamma radiation from the center of our galaxy using data from the Fermi Gamma Ray Space Telescope collected from June to December in 2022. Scientists tried to figure out the source of these signals and discovered that X-ray radiation appears approximately once every 76 minutes, and the accompanying gamma radiation lasts twice as long. This alignment of scientist thoughts indicates that the signals are created by a single physical mechanism and are undoubtedly interconnected. According to telescope data, the signal source is in the region of the supermassive black hole Sagittarius A*, located almost 27,000 light-years from Earth. But black holes themselves can't emit anything because they're confined by an area called the event horizon, which even light can't penetrate due to immense gravity. However, in one way, supermassive black holes can emit radiation due to turbulence in the surrounding gas and dust. Around Sagittarius A*, there's not enough matter for radiation, let alone periodic radiation. Nevertheless, something generates radiation near the black hole, and scientists believe it's a unique hot magnetized gas clump rotating around it at a speed of approximately 320 million kilometers per hour, which is 30% of the speed of light. According to scientists, the gas clump is connected to a strong magnetic field, which synchronously accelerates the particles, causing them to be released, and we register this as radiation. Typically, black holes consume approaching objects and feed on them. Most likely, this awaits the gas clump, but until that happens, scientists are continuing to observe these repeating FRB signals from the galaxy center to find an explanation. According to one theory, these signals in the galactic center may appear due to the generation of coherent radiation. At its core lies the process of electromagnetic radiation interacting with a simple quantum system that has only two energy levels, ground and excited. On the ground level, the system is in equilibrium, meaning it doesn't exchange energy with the external environment. However, when an external force acts on such a system, it provokes changes in the particle states, like a conductor making the orchestra play. Only in our case, it's not sound but radiation. This transition between states has a property called coherence, meaning the phase coherence of oscillation. Simply put, if forces of the right frequency and intensity constantly affect a system, it can spontaneously produce powerful signals with a certain periodicity. However, scientists are convinced that such a particle orchestra can't exist around such an active object as a magnetar because everything would just scatter. Instead, astronomers imagine an asteroid flying around the magnetar, triggering energy bursts every 22 minutes. The only problem is that an asteroid with such a rotation period would be too close to the magnetar, and it would just tear it apart. It seems without unraveling the FRB mystery, we won't budge an inch. But a large team of American astronomers and physicists recently decided to do just that. Scientists have already managed to discover dozens of new signals using the latest statistical tools, and their most shocking discovery is that in reality, all FRBs can keep repeating, but we catch them only once. So the mystery deepened. Will we have to consider the most fantastic theory since the 22-minute signal, like many others, still has no explanation? Some scientists are leaning towards an artificial origin. Alo Bentmanosi and Lingham from the Harvard-Smithsonian Center believe that we're actually picking up signals from extraterrestrial radio transmitters powered by star energy. According to L and Lingham, it could be used to power photon engines of spacecraft or probes moving through interstellar space at speeds close to the speed of light. If we're indeed catching signals from a massive extraterrestrial emitter, it must be at least twice the diameter of our Earth, or it could be an artificial structure on a stellar scale. It's believed that any technological civilization reaches a point where planetary resources simply are not enough. One solution is to max out the resources of the nearest star, surrounding it with a Dyson sphere that traps energy inside. To us, it would look like an exotic star radiating infrared waves. What if more advanced civilizations have already built an entire network of these emitters, using them not just as batteries, but also for long-distance communication? Such a massive transmitter could totally produce signals like the ones we get every 22 minutes. An interstellar battery would surely last for many decades of operation. However, no Dyson spheres have been found near the magnetar, which is considered the source of this mysterious signal. Moreover, its magnetic field would instantly shatter it. But with a compact relay, that wouldn't happen. So maybe it's near the magnetar, sending us a signal every 22 minutes, and we just don't see it from such a distance, thinking the anomalous magnetar is sending the signal. And this isn't the first signal from space that could actually be artificial. In August of 1977, Dr. Jerry Ehrman was scrutinizing printouts from the Big Ear radio telescope and unexpectedly saw a signal with the characteristics scientists expected from an interstellar signal. Using various methods, they tried to determine its frequency, and they all gave values within the radiation range of neutral hydrogen atoms. 1420 MHz hydrogen radio emission is considered perfect for space communication because this element literally penetrates interstellar matter. A man was so impressed with the find that he circled symbols on the printout and wrote "wow" beside them. To pinpoint the exact coordinates from which the signal came, it had to be caught again. Scientists kept searching, but the "wow" signal never repeated. Eventually, the signal was attributed to radiation from Earth's surface reflecting off space debris. However, no Earthbound transmitter produces a signal of such strength. Moreover, transmissions on the hydrogen frequency are prohibited precisely to avoid missing signals from extraterrestrial civilizations. But in 2003, scientists had to remember the "wow" signal. That's when the SETI at Home project recorded a new candidate for an attempt by extraterrestrial civilizations to get in touch with us. This was already the second radio signal observed at a frequency of around 1420 MHz. Scientists believe that extraterrestrial civilizations would send us a signal precisely at this frequency if they initiated contact. And this new "wow" signal repeated 3 times. But when scientists tried to determine where it came from, it turned out its source was somewhere between the Pisces and Aries constellations, where there's no star or planetary systems. Due to the enormous distance, the signal was very weak, and the Arecibo Observatory radio telescope held it for only a minute, so it was impossible to make a detailed analysis unless the signal repeated. Therefore, astronomers believe this signal could be anything but a message from an extraterrestrial civilization. However, no other explanations have been proposed so far. The Arecibo radio telescope detected another signal that repeated as many as 9 times over 6 months. It came from a dwarf galaxy 3 billion light-years away. D.A. Ziga from Nanjing University in China, along with his colleagues, studied this signal and concluded that a dead pulsar passing through the asteroid belt captured electrons from its surface, forming signals detected by our radio telescopes. It's such a unique coincidence that it's simply impossible to verify. Maybe we caught a message that we're just unable to decipher yet. Meanwhile, for a solid 30 years now, from a whopping 15,000 light-years away, an unknown source has been trying to reach us almost like demanding attention every 22 minutes. But hey, we're playing it cool, pretending like nothing out of the ordinary is happening. So, how anomalous a signal do we need to get truly interested? Some people think aliens might be a whole lot closer than thousands of light-years away. During a shuttle flight to the International Space Station in 1998, they noticed a mysterious black object. It got catalogued by NASA as 02557. In March of 2017, Mail Online dropped a bombshell claiming it was actually an alien spy satellite secretly taken out by the military. Could it be that the mysterious 22-minute signal was actually controlling this spy satellite? Astronaut Jerry Ross, who was part of the American team, shed light on this mystery. As it turned out, it wasn't a spy satellite at all, just a thermal cover for docking that broke loose from its mounts and went flying away. However, photos of the mysterious black object sparked a series of conspiracy theories. Unfortunately, it's pretty normal when we don't know something. Once we figure out what's really producing those mysterious signals from space, it's sure to change our understanding of the universe. So, which version is closer to you? A super exotic natural object, or maybe, just maybe, aliens?